All right, so looking at this, we are getting into polynomials. So the first thing that we're going to look at is a lot of the vocabulary. Okay, so making sure that if we're given a polynomial, we can identify different parts of that polynomial. So some of the first things that we're going to look at is how to name a polynomial. Okay, so with your polynomial, we are going to first name it off of the degree. So looking at this, when I ask you what is the degree of a polynomial, that is going to be the largest exponent that's in that polynomial. So when I ask you for the degree, I'm just asking you for the largest exponent. So if I'm writing an example of a polynomial that has a degree of 1, that would be like x plus 8. Okay, so that's an example of a polynomial that has a degree of 1 because for this variable, my exponent is just a 1, and that's the largest exponent for that polynomial. Okay, now looking at this, if I were to name it using that degree, because it only has an exponent of a 1, if I'm going to graph this, we should know that it's going to be a straight line. So anything with just a regular x, no other exponents, that's going to be a linear function. So if I am naming this polynomial, this would be a linear polynomial. Okay, and it's linear because of that exponent of a 1. Now if I'm naming it using my terms, remember terms are separated by addition and subtraction signs. So when I'm looking at this, here is my first term, and here is my second term. So this one would have 2 terms, and I'm going to name that a binomial. So any polynomial that has only 2 terms, we can name it as a binomial. And then if it has a degree of 1, that would be a linear polynomial. Okay? So an example of something that has a degree of 2, and we've talked about this, and we've actually done this. So we've done this previously with a quadratic. So looking at this degree would be a 2 because this is the largest exponent. And remember when we graph these with that x squared, that is that parabola shape. Okay, so if I'm naming it off of this second degree, that would be a quadratic. So again, something very familiar that we've already done. And then if I'm naming it using my terms, looking at this one, I have 1, 2, 3 terms. So because I have 3 terms in this example, that would be called a trinomial. All right, then keep moving on. We've done the 3 exponent as well. So if I have just x to the third minus 4. So looking at that one, that x to the third minus 4, that degree would be 3 because that's the largest exponent. And if I'm naming this one, again, we've done this before, that would be a cubic polynomial. Okay, now again, this one has 2 terms, so that again is a binomial. So these 3 we've actually already done previously in Algebra 2. So remember the exponent with just a 1, your degree of 1 is a linear. If it has an exponent, a degree of 2, that's your parabola right here, which is a quadratic. If it has a degree of 3, and remember we graphed these, it looks similar to that, and that is your cubic polynomial. Okay, so these 2 might be new. So x to the 4th, and I'm just going to leave it like that. So if I look at x to the 4th, that would be a polynomial that has a degree of 4. Okay, so if it's the 4th is your degree, that is called a quartic. So that would be a quartic polynomial. Now looking at this, if I ask you to name it by its terms, realize this is only 1 term. There is no addition or subtraction. So if there's only 1 term, that is called a monomial. All right, and then looking at the last one that we're going to talk about today, a degree of 5. So I could have 3x to the 5th minus 2x squared plus x minus 6. So that would be an example of a polynomial that has a degree of 5 because again, that's the largest exponent. And if I am naming this one right here because that degree is 5, that is called a quintic. Okay, so this is how I name it using your degrees. It's all based off of your largest exponent. And then for the name of the terms right here, so if I look at this one, I have 1, 2, 3, and 4 terms in that one. So this one is 4 terms. So for our purposes, we're just going to call that a polynomial. Okay, so we have monomial, which is 1 term, binomial, which is 2, and trinomial, which is 3. Anything after 3, we're just going to name it as a polynomial. Okay, but your degree is looking off of your largest exponent. So an exponent of a 1, a degree of 1 is linear, degree of 2 is a quadratic, degree of 3 is a cubic, and then degree of 4 is a quartic, and then the last one, your 5, is a quintic. Okay, so now we're going to kind of work on some of that. Now, before we move on some of those examples, some other vocabulary that you're going to see. So we know the degree is your largest exponent. We're also going to have what is called our leading coefficient. So remember, a coefficient is a number that is in front of a variable. And because it is going to be our leading coefficient, when I'm asking you to identify the leading coefficient, it is going to be your coefficient that's in the front. And it has to be in standard form. So that's the key part here. So it's going to be your coefficient that's in front when it's in standard form. And if you look at all the examples that I did, those are all in standard form because I have the largest exponent in the front and then it goes decreasing from there. Okay, so looking at this, if I were to look at this last example and I say what is the leading coefficient, that would be the 3. Okay, and then we have what is called our constant. And remember, your constant is the number that has no variable. So it's the number that's by itself, and your constant should always be at the end when it's in standard form. So this constant would be a -6. Okay, so just some other vocabulary that we're going to see today. One of the biggest concepts, again, is that we can find the degree of any polynomial, and then we can identify how to name it by the degree and how many number of terms it has, and then identify leading coefficient and the constant. Okay, so looking at the first couple examples, that's what we're going to do. We're going to put it in standard form because it needs to be in standard form, and then we're going to identify all these different parts. So if I am putting this one in standard form, again, that means I have my largest variable in the front. So I have x to the 4th and x squared. So this one stays in the front because that's the largest exponent. And then I'm going to go in descending order. So now I'm going to put my -1/4 x squared, and then I'm going to put that constant at the end, the +3. So again, your constant is always at the end when you're putting it in standard form. Your exponents are going in descending order. Okay, so if I ask you to classify this by your degree, so when I'm classifying it by my degree for this polynomial would be 4. Okay, so if my degree is 4 and I'm asking you to identify and classify that, that would be a quartic polynomial. Okay, next one, if I classify it by the terms, I have 1, 2, 3 terms. So because I have 3 terms, that would be a trinomial. So when you name a polynomial, you can name it 2 different ways based off of the degree and how many terms it has. Okay, and then if I'm asking you to identify the constant, remember that's the number by itself. So that would be a +3. And then the leading coefficient, once it's in standard form, is that number in the front. So that would be the 6. Okay, so that's how we go about identifying all of this information. Again, one of the most important parts is that I can put this in standard form. So if I look at the next one, this is my largest exponent, so I'm going to put that one in the front. And then I'm going descending order. So next would be the x squared. And notice I'm keeping my sign. So this subtraction stays with the 9. So that is a -9. That negative stays with the 3. And then I have a +3x. And then I have that -8. So that would be my standard form. Okay, so now I'm going to classify it based off the degree. Again, the degree would be 3. So that would be considered a cubic polynomial. And if I look at how many terms it has 1, 2, 3, 4 terms. So because it's 4, we're just going to classify it as a polynomial. And then the last two, identifying constant and leading coefficient. My constant would be that -8, so that subtraction does stay with that 8, so that is a -8. The leading coefficient in the front would be a -9. All right, and then the last one, again, putting them in descending order. So the x to the 5th is my largest exponent, so that's going to go in the front. And then going down from there, this is a +5, so I'm going to put a +5, x to the 3rd. And then I have a -3x squared. So that would be your standard form. So looking at this, the degree of this polynomial is 5. So because it's a 5, that would be called a quintic polynomial. And then looking at the terms, I have 1, 2, 3 terms. So that would be called a trinomial. And then identifying the constant. Now looking at this one, I don't have a constant here. I don't see a number that doesn't have a variable. So my constant would just be 0. Okay, I realize if I put a plus or a -0 here, it's not going to change anything. So your constant is 0. And then that leading coefficient in the front would be the -2. Okay, so again, important vocabulary that we're going to kind of see throughout this lesson, making sure we can name these, and again, identifying the degree and then that leading coefficient. All right, so next concept we're looking at is how to find the end behavior of a graph. Okay, so when I'm looking at end behavior of a graph, I'm asking you, how are your x's and y's behaving? Okay, so you're looking at your behavior of your x values and y values as they approach infinity and negative infinity. Okay, so we're looking at the behavior of the x and y values as they're approaching positive and negative infinity. Okay, so looking at this, when you're writing these, we're going to use a little bit of abbreviation so we don't have to write approach every time. So we're going to say as x, and we're going to draw a little arrow for approaches, infinity. So as x approaches positive infinity, what is your y value approaching? So what is your y value doing? Okay, and then also as x is approaching negative infinity, what is that y value approaching? Okay, so realizing this is always how we're going to write this. Okay, as x is approaching a positive infinity, your f of x, which is also your y value, approaches, we got to figure that out. And then as x approaches negative infinity, what is your y value approaching? Okay, so this is what we're going to be using. And looking at this, this is all going to be based off of your degree. So we're going to look at your degree as far as is it even or is it odd? And then we're going to look at your leading coefficient. And decide, is it positive or is it negative? So that's what we're going to look at when we're trying to look at the end behavior. Okay, so we do have 4 graphs here that are going to be kind of like the generic graphs that we're looking and trying to figure out what these rules are. So we're going to look at the degree, if it's an even or an odd degree, and then we're going to look at your leading coefficient as if it's a positive or if it's a negative. Okay, so looking at this, and again, these are kind of our generic ones. So if I'm looking at this first one right here, remember, we always read a graph from left to right. So this graph is starting over here, and I'm tracing it, and it's going up that way, okay? The degree of this graph, and we're going to talk about how to find the degree here shortly. So looking at the degree of this graph, this degree right here, so remember, it's going up, going up, going up here. So when I look at the degree of that one is an odd degree, okay? So it's going to have an odd degree. And then looking at your leading coefficient, we've talked about this before when we're looking at a graph and you're trying to see basically, is it going up or down? We've talked about transformations. So that leading coefficient, realize if it's a positive, that graph will be going up. If it's a negative, that graph will be going down, kind of like that a value when we were doing quadratics, square root functions, cube root functions, and all of that. Okay, so if I'm looking at this graph, I'm starting here, left side, and I'm going to the right. That graph is going up. So this would be a positive. Okay, so for this one, it's an odd degree and it's a positive for that leading coefficient. So looking at that, if I start to write my end behavior, as x approaches positive infinity, your f of x is approaching what? So the positive infinity, remember, is over here. All my x values are getting larger over here. So as x is approaching positive infinity, which means as this graph is going in this direction, my y values are also going up. So those y values are increasing, so that means my y values are also approaching positive infinity. Okay, so that would be the end behavior for that positive infinity. So here, as x approaches a negative infinity, your f of x is approaching. So if I look at this one, here's my negative side. So these are all my x values that are going negative. So this is the negative side of my x-axis. So those y values are going down. So because those y values are going down on this side, they are approaching negative infinity. So that's how we want to look at our end behavior. So we're looking at the graph as your x is approaching a positive infinity, which means it's on this side of the graph. Your y values are increasing. They're going up. So that's a positive infinity that they're approaching. And then it's the opposite for that side. Okay? So now if I look at the next one, this degree is also going to be odd. But this time when I'm looking at the leading coefficient for this one, I'm starting over here on the left, I'm tracing it, I'm going this way, and when I go to the right, it's going down. So this leading coefficient would be a negative. Okay, so if I write my end behavior for this one, so as x approaches a positive infinity, your f of x is approaching, so again, positive infinity is on this side, so these are where all my x values are becoming positive. So here, if I go that, those y values are going down, so that one's actually approaching a negative infinity. And then as x approaches a negative infinity, so on the other side of the graph, what is your y values doing? So if I look at this side of the graph, here, those x values are going to the negative infinity, those y values are actually going up towards positive infinity. So realize we've talked about kind of like the inverses. So if I'm looking at this one, realize this was a positive leading coefficient, this was a negative, it flipped direction. Okay, so notice how my y values here, what they're approaching, flipped as well. All right, and then these last two, these are the two that would be even degrees. So both of these are going to be even. But when I'm looking at the leading coefficient, again, look at the direction of your graph. So when I'm looking at this one, I'm starting over here on the left. I'm going this direction, and realize they're both going up. So this would be a positive. This one for the leading coefficient. When I'm going from left to right, these are both going down. So that is your negative leading coefficient. Okay? So now looking at this. So as x is approaching infinity, so again, I'm just looking at this side of the graph. So as I'm looking at this side, those y values are going up. So those y values will be going up. So my f of x is also approaching positive infinity. Now if I look at this one, as x is approaching a negative infinity, so that's the other side of the graph, what are my y values doing? So if I look at this side of the graph, these are actually also still going up. So that would be a positive infinity as well. Okay, so for both of these, because they end up going, both of them go up on both sides, they're actually both approaching a positive infinity, which means this is going to be the opposite. So here, as your x is approaching a positive infinity, your f of x is approaching, so here on this side, it's going down. So that would be a negative infinity. And that's going to be the same for the other side. So as x is approaching a negative infinity, your f of x is also approaching a negative infinity. So on both sides, they're going down. So this is what it means when it asks for the end behavior. Okay, you're looking as your x is approaching positive and negative infinity, what are your y values doing? So obviously, looking at a graph, it's pretty easy to tell. These are going to be your basic rules, okay? So for the odd, and then one's positive, one's leading or negative, those are going to be your basic rules. So now we can use these for if I'm given just the function. So now I can use this and say, okay, I can determine the end behavior just based off what I just did. So it might help you to sketch the graph. So you should know if this is an x to the third, okay, that degree is a 3, so this is a cubic polynomial. So that means my graph would look like this. We've already graphed those before. Okay, so looking at this, if I'm asking for your end behavior, my degree, it is a cubic, but here my degree is odd, and then that leading coefficient is a positive. So if I look at an odd positive graph, which was right here above me, okay, that tells me what my end behavior is going to be. And if it helps for you to graph it, graph it. So as my x is approaching a positive infinity, that's going up on that side. As it's approaching a negative infinity, it's going down on that side. So that would be the same. So that would be as x approaches positive infinity, your y value approaches a positive infinity as well. As it approaches a negative infinity, your y value also approaches a negative infinity. Okay, it's the same thing that we just looked up at the graph. But again, you can sketch it to help you as well. All right, so here, negative 2x to the fourth, that means my degree is 4. So looking at this, this would be a quartic polynomial. because that degree is 4. So looking at this, when your degree is 4 and it is a negative, it's upside down. So this is going to be kind of like your generic graph right here. And we can also graph it and see if we can graph it in our calculator. So I can do negative 2x to the 4th plus 8x to the 3rd minus 8x squared plus 2. And you see how it looks very similar to what we did up here. So we can just kind of sketch that graph. Looks like that. So if I'm looking at this, this is an even degree, and that is a negative leading coefficient. So I have an even degree with a negative leading coefficient. Again, my graph is very similar to the one that I did up here. So looking at that, as my x is approaching a positive infinity, my y value on this side is going down to a negative infinity. And then as it approaches negative infinity, your y value is still approaching a negative infinity, because remember, on both sides of that graph, they're both going down. So your end behavior, again, it's all based off of your degree, if it's even or odd, and then your leading coefficient, if it's a positive or negative. These are kind of like your generic rules as far as when you're looking at that. All right, so now we're still going to use that concept. And we were looking up here, so realize when we were looking at this a minute ago, and I told you that the degree here was odd, and I told you this degree was odd, it's all based off of your turning points. Okay, so your turning point, it's kind of like your curve. It's where that graph changes direction. So when I look at this graph has 2 turning points. So it has one here and one here. So it has 2 turning points. That means that that exponent, that degree, would be x to the 3rd. So I just take my turning point and I add 1 to it. So if I'm looking at a graph and I say, what is the degree of this graph? I would look at the turning point and I find 2 of them. You just take that and add 1, so that gives me 3. So like right here, same thing. Here's a turning point and here's a turning point. So those are 2 of them. So that means this degree would be a 3. So that would be x to the 3rd. So again, same as like right there, that's why they're odd. If I look at this one, I have 1, 2, 3 turning points. So for this one, because I have 3 turning points, this would become x to the 4th. That degree would be 4. And it is the same for this one. 1, 2, 3 turning points. So that degree would be x to the 4th as well. Okay, and that's what we kind of looked at when we graphed this one a minute ago. That x to the 4th, that's what our graph looks like, just like that one. Okay, so that tells me I can take my turning point. If I'm looking at a graph, I can take my turning point and add 1, and it's going to tell me what my degree is. Okay, so for your graph, you're looking for the curve. So where does it change direction? So that's pretty easy to find on your turning point for your graph. If I'm given an equation and I say how many turning points are in that equation, so looking at this, if we kind of work backwards. So here I was given a graph and I said, okay, what's the degree? That degree I just took in and add 1. Okay, so here if I say, okay, looking at this, how many turning points would I have? So when I looked at this, we had 1, 2, 3. I'm just working backwards from what I did here. So if I'm given an equation, instead of adding 1 like I did for a graph, here you would take the degree and you would subtract 1. And that's going to tell you how many turning points that equation would have, or that graph would have. So for example, if I give you 3x to the 5th minus 4x to the 3rd plus 8. And I can say, okay, if you, without graphing it, tell me how many curves this graph would have. Okay, so I know the degree is 5. So if I ask you how many turning points would it have, I would just take 5 minus 1. So that means that graph would have 4 curves in it, 4 parts where it changes direction. So the turning points you can use in both the graph and the equation. So looking at this, if we use that example, here I'm going to ask you what is the sign of the leading coefficient, and then what is the degree of the function. So they're just giving us a graph. So if I ask you, what is the sign of this leading coefficient? That's either a positive or a negative. So if I look at this graph, realize this graph is facing down. It does go up right here, but ultimately, when I trace it, those are both going down. So that means the leading coefficient here would be a negative. Now, if I ask you what is the degree of this polynomial, I'm looking at for those turning points. So right here I have 1, 2, 3 turning points. So I have 3 points on that graph. That's where it changes direction. So because I have 3 points here, and I'm asking you what is the degree of this, I would do 3 plus 1. So the degree would be 4. Okay, so that's just like what we just talked about here. For that turning point, there was 2 of them. If I add 1, that tells me that's an x to the 3rd. That degree is 3. So if I'm given a graph, find the number of turning points and then add 1 to it, and it tells you what the degree is. Okay, same thing right here. Look at the leading coefficient first. So if I'm looking at the leading coefficient, if I've traced this graph, I'm starting on the left and I trace it to the right. Right there, that graph was going up. So that tells me that is a positive leading coefficient. And then for the degree, look at how many turning points you have. Be careful with this one. I have 1, 2, 3, 4. So those are 2 different spots where that curves. So I have 4 different turning points. That means my degree of that polynomial function would be 5. All right, last one here. So this one pretty easy. This is a parabola. We've looked at this before. That's a quadratic function. So it is facing up. So that is a positive leading coefficient. And then for your degree, again, I only have 1 turning point. So I'm going to do 1 plus 1. So that degree would be 2. Okay, so everything is tied to that degree and that leading coefficient today. So that's some of the main vocabulary we need to make sure you understand. All right, and the last part. So I gave you an equation, and you had to be able to find what the degree is. Whoops. I gave you the equation. We talked about what the degree was here. I gave you a graph. We had to find the degree. Now you also have to be able to find degree from a table. Okay, so if I give you a table, all you have to do is find the differences of the y value. So you're going to find the differences of the y values, and you are going to continue to do that until you get all of them the same. So you want all of those differences to eventually become the same, and that's going to tell you what the degree is, okay? And again, it is the y values that we're subtracting. So right here, I am just subtracting, and I'm going to go down. Sorry, we're going to go down and we're going to subtract all of those y values. So like right here, I'm doing 65 minus 5, which is 60. Be careful with your double negative. So here I'm doing 5 minus a negative 5. And that gives me a positive 10. I have negative 5 minus a negative 1. That gives me negative 4. I'm going to continue this. Negative 1 minus 5. Gives me negative 6. 5 minus 25 is a negative 20. And then 25 minus 95 is a negative 70. Now, obviously, those are not all the same number. So now we're going to continue this. So now I'm going to continue, and I'm going to do this a step further and subtract these y values. So now I'm doing 60 minus 10, which is 50. Be careful here, you have 10 minus a negative 4, gives you 14. I'm going to do negative 4 minus a negative 6, gives you 2. And then I have negative 6 minus 20. Oops, almost made a mistake. Negative 6 minus a negative 20 gives you 14. And then I have negative 20 minus a negative 70, gives you a positive 50. Okay, some of these numbers are starting to repeat, but again, they're still not the same. So now I have to do this again. So I'm doing 50 minus 14. So we are just subtracting all of these values until we get all of them the same. Okay, 2 minus 14 is that negative 12. And then 14 minus 50 is a negative 36. Still not done yet because they're not the same. So now I'm going to continue subtracting. So I got 36 minus 12 gives you 24. Here I have 12 minus a negative 12, also gives you a positive 24. And then here, negative 12 minus a negative 36 gives you positive 24. And that's what we're looking for. We are looking to where all of these are the same value. So when I'm trying to figure out what the degree is, this was my first subtraction, second, third, and fourth. So this would be the fourth degree. And if I ask you to name that fourth degree, remember that would be called a quartic polynomial. So if you're given a table, all you're doing is subtracting those y values until you get them all the same. However many times you have to find those differences, that is your degree. Okay, so let's do one more of those just to make sure you understand it. So looking at this one, we're gonna do the same concept. I'm gonna start subtracting those y values. So negative 16 minus 1 is a negative 17. 1 minus 4 is negative 3. 4 minus 5 is negative 1. And 5 minus 16 is a negative 11. Obviously, those aren't the same. So now we're going to continue to subtract these. Again, watch your signs. So I have a negative 17 minus a negative 3 gives me negative 14. Negative 3 minus a negative 1 is negative 2. And then negative 1 minus a negative 11 is a positive 10. So still not the same. Try it one more time. So I have negative 14 minus a negative 2 is negative 12. And then negative 2 minus 10 is also negative 12. So there, that's where we have the same numbers. So this was 1, 2, 3. So looking at that, that would be the third degree. And if I ask you to name that one, remember third degree, that would be a cubic polynomial. Okay, so again, a lot of vocabulary today. One of the biggest concepts, making sure we can find degrees from either a table, a graph, or an equation, and then also being able to identify those end behaviors.